Hi everyone and welcome to Productive C#. In this video, I'm going to show you how you can implement efficiently the top K problem using C# and a min heap data structure. So the top K problems is very simply returning the top K elements from a data set that are the largest or the smallest, for example. In this case, I have a list of books and I want to return the top 3 books in terms of number of pages, so the longest books available in my data set. And I want to do it as efficiently as possible. Here I have a list of books. I have a method that I defined called top as an extension method of an enumerable book, and that will be taking a k as a parameter and will return the top k elements from the books. And the book is a record chart that contains a title and the number of pages, simple as that. So most of the time, you don't really need to do this problem efficiently. You can just use a simple link to solve this problem. If you don't have a lot of elements in the list, it's not a big deal. Link works pretty well. So let's start with that so that you can see what the kind of basic link-based implementation is. And you just need to do a simple sorting of the books based on the number of pages. And after that, you can use the link take method to specify k and to just return the top k elements after you've ordered them descending. So if I run this code, it should give me the top 3 books that are book 4, 1, and 6. Simple as that. This is obviously n log n in terms of complexity because it's doing a full sorting in order to calculate the top elements. Okay, but I want to do it more efficiently. I want to do that by using a min heap. So I'm not going to explain what a min heap is because I already created a video about it and explained the data structure in depth and how you can implement it from scratch using modern C#. But we are lucky that we can use a data structures already present in the framework called PriorityQueue, that under the covers is implemented using a min heap. That is exactly what we need to solve this problem. So a min heap, in a nutshell, is basically a data structure that allows me to organize my items so that it's very easy to immediately know what is the minimum element. So in constant time, I know what the minimum element is. And this is very useful because the idea here is to scan through the list of books and create a min heap with just k elements. And because I always know what's the minimum of the k elements, as soon as I see a new element, I know if that is going to belong or not to the final result or not. We're going to get there in a moment, and it's going to become a lot more clear. Let me start by creating a priority queue. So in .NET, a priority queue requires you to specify the type of object you want in the queue and the priority. In this case, you're going to use an int as a priority. That's going to be the number of pages. I'm going to scan through all the books, okay? And then if the priority queue size is less than k, in this case, I can just simply add the element in the queue, right? So until I have k books, the first k elements I'm going to see as I scan through the list of books, I know that up until now, those are effectively the top k elements. Now I need to see what to do as I progress in scanning the list of books. Okay, so I just need to add a book, but I also need to specify the priority, that is book.pages. Okay, what happens next is I don't want to keep adding element here like that. I could, but I don't want to do that because I only want the priority queue to be containing just the top k elements. So what I need to do is to take a look at the current number of pages in the book that I'm trying to consider. And because I know it's extremely efficient to know what is the book with the minimum number of pages in the top k books so far, I can immediately know if I can discard the new book I'm looking at or not. So what I need to do, I use the method pick in the priority queue that effectively return the minimum element inside this priority queue. that for us, this means is the book with the minimum number of pages amongst the books that I consider so far the top K books. That's very important. So I'm going to do this check. So if this is the case, and only if this is the case, I need to consider this book. And that means now I'm going to have K plus 1 books, and I need to make sure I get rid of the book that is not going to be in the final result. And which one is going to be? Basically the root of the min IP, the minimum, the book with the minimum number of pages that the queue is the one I'm going to need to replace with a new book. So what I need to do is basically simply the queue, an element from the priority queue. This one is the book I'm going to now remove from the result set, and instead I'm going to add in the list the new book that I'm looking at right now. So that means that as I go through the list of books, I'm always keeping inside the priority queue K books, and I know at the end of the scan, I consider all the books. The priority queue will contain only the books that are the top K books. This is actually quite amazing. The final things I need to do is to just simply dequeue all the elements from the priority queue and just return them as the results, because everything inside the priority queue now is part of the result set. So I'm going to do a simple loop for K times what I'm going to do, and I'm going to do a yield return of the pq.dequeue. And that's it. Now I implemented top using a priority queue. Is using very little memory because it's is only containing K books at a time, and it's very efficient to do in queue, and the queue from a priority queue is just logarithmic in terms of complexity. So this is basically a lot more efficient ways to find the top K elements. And you can do this as many times as you want, and it's going to be a lot more efficient. If I run this code, let's see if it works. And you get the top 3 books. These are not sorted because, remember, this is a min IP, so it's basically sorting by the number of pages. But it doesn't really matter because the problem that we have is to find the top K elements. It doesn't really matter what's the order of them. If you want, you could reverse the list at the end and you would get the actually top 3 in order. But this is a very good example on how you can use a min IP data structures to efficiently calculate the top K elements from a list in a logarithmic time. That is a lot more efficient than just doing a full sort and then just return the top elements. So I hope this is very useful, informative, and very interesting to learn how you can use a priority queue in .NET, how you can leverage the min IP data structure. If you're really interested to deeply understand how to implement in queue and the queue in a min IP, if you want to understand how you could actually create a min IP yourself, take a look at my other video where I went in depth so you can deeply understand how a min IP works. But as I said, in order to solve problems that requires this sort of data structures, you don't need to implement it yourself. You can use the priority queue in .NET. That is very handy. You can solve a lot of problems with it, like this problem, like doing a star or search algorithms, or you're going to do a IP sort and anything like that. It's a very, very interesting data structure that helps you to solve efficiently a lot of search problems like this. Thank you very much for watching.